So my name is Jay Friedenberg, and I'm professor of psychology at Manhattan College. I've been teaching there, believe it or not, almost 30 years. I've written a number of books in topics in cognitive science, artificial intelligence, dynamical systems. So I do research in visual perception, which is an area unrelated to AI, but it's of great interest to me, and it has given me a grounding in science and how to apply science to these other areas. Well, in many, many ways. In fact, in some sense, the two are part of the same field, because we have to understand how the human brain learns and what its architecture is like. And in fact, if you look at many of the deep neural networks that we have now, some of these adversarial networks, GANs, they are actually based to some degree on how the human brain actually works. So you've got nodes, which are equivalent to neurons with connections between them. You've got layers, you've got relationships between layers. So studying the brain, studying the neocortex, the way neurons are connected to each other, all of that stuff can inform how we would design an AI system. Like we could learn a lot from the brain, not just the brain, but also just looking at psychology in general, like people's attitudes, there's perceptions. So there's this bigger issue of, if you're going to introduce AGI into society, how are people going to react to it? What are their perceptions going to be, right? How do people view technology? And even this other area of cyber psychology, where you look at social media and how people's identity is so tied up into the way they interact with other people online. So so it's like many different ways that cog science and psych affect AI. I don't think it's necessarily a recipe for disaster. We've been augmenting ourselves for a very long time now. We're augmenting using the internet. The internet is a form of augmentation. It's an outsourcing of long-term memory. There's this idea of the extended mind thesis, it's called, where, that in fact technology is just an extension of the human brain. So, but even beyond that, any tool use, technology in general is a form of augmentation. So I think, when we talk about brain-machine interfaces, things that are more radical, where we're merging our bodies with technology, that may sound exotic, but it's actually just a trend of what we've been doing, throughout our history. It's interesting, if you look at this, you see that tech is getting smaller, and it's been getting closer to the body, because it used to be computers were in rooms, and then they were on our desks, and then they were in our laps, and then they were in our hands. So what's the next step? It's to actually have them have a direct neural interface. And you do in fact see that people are doing research on this. Some people in Pittsburgh are doing a lot of work on BMIs. For helping quadriplegics and people who, get paralyzed. And what's amazing about these things is you can put a chip in their motor cortex that can read, not with great accuracy even, the neural firings, beneath this electrode array, and they can train someone to control a computer mouse, or to play a game, or to use a robotic arm to pick up a coffee mug and bring it to their mouth and actually drink. So, right now we are using that form of augmentation to help. I don't know if you would call that augmentation, because it's more like helping people who are disabled. But the logical extension of that, and I think where we're going to be going with it next, is that you're going to have a brain implant, and it's going to be, enhancing baseline human capabilities, giving us access to, the internet. Google's vision system is a pretty crude kind of first step towards that. So another form of augmentation that's not so radical, perhaps, involves contact lenses, something more akin to Google Glass, which I think was sort of strange because it didn't get wider adoption. I mean, there are a number of issues, VR goggles, but something that's smaller and a little more sleek than I think what Apple just came out with. Yes, of course. I mean, I think a lot of this stuff is, I have more of a balanced approach. I don't see myself, sometimes there's like the doomsayers, it's all the Terminator scenario, they're going to take over. There's other people that, like Ben, that are more, just, it's going to be a techno utopia. Like transhumanists tend to be a little more optimistic in this area, and they say it's just going to be, we're going to upload our minds and become super intelligent. And I think I have a little more of a balanced approach. I think it depends on how we as humans now implement this technology, whether it could be good, bad, it could be somewhere in between. There's a number of different pathways there, and it's how we guide the future. People like to think of the future as not something that, happens to us necessarily, right? That's a very passive view. The future is something that we make for ourselves. If we as humans have, we shouldn't have this deterministic view of the future as like, just throw up our hands and there's nothing we can do about it. We're the ones right now that are building these things and designing them and developing the regulation, the legislative systems that are going to govern how they're used. The corporate, you have different corporations that are working on these things. So yeah, we have to go about it in an ethical manner. That's for sure. We have to keep ethics involved. So is there a potential for danger? Of course. Intelligence is very powerful and superintelligence is super powerful. So we got to be careful about the way we go about doing it. Is it going to be utopia? Is it going to be a dystopia? Well, I think probably it'll be like most humans, we tend to muddle through, so it might be probably somewhere in between. Oh, that's an excellent question, because that has to do not just with technology, right? But that's a philosophical question that's been pondered for millennia, so it has to do with a lot of human endeavors, not just tech. And my view is that free will versus determinism is the wrong question, that the question is phrased the wrong way. It is not free will versus determinism. I see it as more of a continuum, and where there are systems in nature that are much more determined. If you're like an oxygen molecule, there's statistical mechanics. You can describe like how those things operate with a high degree, if you're a very simple agent, if you're not an agent, if you're just like an object, right, and you have like external forces acting on you and there's no internal computation or perception or anything going on, like, I don't know, like imagine a particle of sand or something, right? That's determined. You can like with much greater degree of accuracy predict what's going to happen to that thing. If you're talking about a human being all the way on the other end of this spectrum, where humans are very complex agents, we take in information about the world, we process it, we make decisions, and then our actions are based on those decisions. That sort of internal decision-making and planning process separates us a bit from the environment. Maybe one way to think of it is if you're on a diet, right? Like on a diet, it's more deterministic if you're just if you're just given to your internal physiology and those regulatory factors. But your frontal lobe can override those signals, right? So we have the capability to inhibit our emotions, to be able to evaluate information, right? So I think human beings can train themselves to be more independent of both the external factors that impact upon us that might be more deterministic, as well as the internal factors, right? Because it's kind of like both. So, and then there's things that are in between, like animals, right? So animals are more governed purely by physiology, and perhaps less by cognitive decision-making mechanisms. So I tend to see it as a slider, and where depending on what kind of system you're talking about, decision-making capability, the sophistication of the decision-making capability that this agent has, that's going to skew it more towards one end. And when we're talking about artificial intelligences, whether they're equivalent or greater than us, AGIs or ASIs, the same things apply. The same thing. It's still a physical system. It's still governed by natural laws. And, whether it's going to decide that it wants to do something versus just we can predict what it's going to do based on the inputs we give it, that all depends on its internal complexity and its internal planning capabilities and things like that. So I would say that this argument does not change that it's applicable for inanimate objects, biological animals, humans, and AGIs as well. It's interesting because people want to believe in free will, right? We want to believe in free will because it gives us agency. In fact, in a way, that is the definition of what agency is, right? Because the agent has control over its actions and its environment. But on the other hand, so there's psychological reasons for wanting to believe in determinism. But on the other hand, science kind of loses its power if it can't do prediction, right? If all we have is vague probabilistic estimates that sort of dissipate as the farther out you get into the future, then that implies that science doesn't have. So I've heard scientists say, well, if you adopt free will, then you're basically saying science's power, doesn't have any power. But that view is, again, I think this sort of dimensional thing, explains that. Yeah, this question comes up a lot, right? People tend to think creativity is the last bastion of humanity. Machines will be able to do everything else. People don't get worried if they can do math better than us, right? Because it's like math is this very formal system with rules. But creativity, if you're a painter or a poet, right? That's the human soul. That's this ineffable essence that you'll never be able to capture. Bullshit. Creativity is a process that takes place again in a physical system. It can be described and understood just like any other cognitive process. Creativity there's a neuroscience of creativity. So your brain is doing something when you're being creative. If we wanted to have someone paint a landscape painting and then we could do high image resolution, we would be able to understand the neural information processing that takes place during the creative act of, that particular creative act. So I don't view creativity as any different than any other human capability, right? Why are we putting creativity in a different category from, I don't know, sociology or something, right? I mean, one is a cognitive process. Creativity is cognitive. Creativity perhaps involves maybe more emotions, but that doesn't change the fact that we can't, doesn't mean we can't understand it. It's a process. It's taking place in a information processing system, right? It can be it could be algorithmic, right? There could even be a set of algorithms that can describe how creativity works the same way that learning or memory or other things take place. So I don't put it in some category. Can machines be creative? Sure, right? Because what creativity is just the generation of novel content, typically within a genre, within a rule-governed system, right? So if you're a creative poet, if you're a creative haiku poet, right, the rules for how you create haiku, it's not like randomness is not creativity, because then a random number generator would be creative. So to be creative, it might involve an element of randomness, but it's also rule governed. So the first thing they tell you as an artist is you learn the rules, then you forget them, and then you can express yourself operating within that rule-governed system. So, yeah, I think machines can and have been generating poetry, paintings, music. There's a company called Ava, which does soundtracks for video games and film, and their stuff is trained the way other generative models are, and it creates pretty emotionally moving music. So whatever genre you care to pick, there are already examples of machines that are being created in these different ways. Can you ever create something that's totally new? I don't think so. I think like what you are is you're taking existing elements and you're combining them together in a unique combination. So if you're making music, the elements are notes, right? If you're painting, it's pigments. If you're writing a novel, it's words. So is anything ever completely new? In the arts, I think the answer to that is no, is that it's really combining existing elements together in ways that it hasn't been done before. Yeah, I'm working on a new project looking at ethics and how, people talk about value alignment, right? That's the big Stuart Russell and many others now are saying that if we're going to create AGI, we got to get to align with human values. Definitely. But people generally think that there's no such thing as human values, but there's a lot of psychological research that it turns out shows that that's not the case. Like, there's a lot of overlap in human values. Yeah, they're different cultures. People tend to amplify the differences when in fact there's a lot more commonality than we tend to, like don't murder, don't steal. It's like in every religion, these values. So I'm interested in how, like, can you reduce, like, can you go from all these like values and reduce them down to a smaller set of maybe like 10 or 15 or something like that, right? So get a low-dimensional space of like all this other complexity, and then say, okay, these are the metrics we should now be trying to maximize. Maybe another problem I have with maximization is that like using one metric at a time is just so limited. You've got to use like multiple metrics. So like, what if we throw all these values in there and then we try to maximize all of them in some sort of weighted scheme? Like, that would be interesting to see, right? So that's what I'm kind of interested in now is, what are these basic human values? How can we align to that? How can we get computers to align to them so that they act they act like nice people, right? They're not nasty and, try to kill us or whatever. And then even beyond that, is there like a suprahuman ethics, like a meta ethics, where you could say there's a set of values, things that are good and bad that are like true not just for people, but they would be true for animals, aliens, intelligent machines. So, and I think there is actually. I think that, for example, I think that all intelligent life, first of all life probably should be treated a certain way. All intelligent life should be treated a certain way. It doesn't sort of matter how it's instantiated. If the alien comes down like it looks like an octopus or whatever, like we'd probably want to, there'd probably be certain ways we would want to treat them and they would want to treat us. That might transcend our own particular species-centric set of values, which have been biased by evolution. So yeah, I think that's really what interests me is, can we come up with a set of universal values, a universal ethics that applies to everything? And that's a challenge. I've got a book contract for that I'm working on now, but that'll be like really interesting stuff to think about. you see this happening. We see this in the history of psychology when it comes to trait theory and personality. I don't know if you remember, like back in the even in the 1800s, there were like hundreds of words to describe what a person would be like: friendly, extroverted, sour, dour, whatever. You have a million words. And then they did some over the years, they did factor analysis and statistical, and they reduced to the big five. So now there's five. They call them the big five basic personality traits. And these things are enormously predictive. They predict a lot of people. They predict your success in life. They predict, whether you're going to be successful with a certain kind of person, who you pick to get married to. So what they did was they took something that was really complicated, right, where there were millions of words to describe what a person was like, and they reduced it, right? And so I think the same thing can be done with ethics. I think you can take the complexity that exists in ethics now, and I think that if you look at it the right way, you can reduce it down. And then from there, that's the starting point, and then you build up to create something that's even bigger.